Hello everyone, my name is Soumya and I'm a PMRF fellow at IIT Gandhinagar. So this is the second week of interaction session for this course on advanced robotics. Having said that, I have some connection problem between my tablet and the PC that I am using. So I'll be going through all the questions. Please engage in questions and answers and discussions throughout. I'll be telling you what all things have to be done. So the very first thing is this DH parameter. Okay. So I think you have already gone through the lecture for this DH parameter. But okay, before showing what is there with me, uh, can someone from your side tell me what DH parameter actually is? Why do we need it? Any answer to this question? Uh, just a very basic answer I want. Okay, so I hope you all have gone through the lecture and DH parameter, as said in the slide, it is a very systematic way to describe the geometry of robotic manipulators. So if it were not there, what you would do is you will go on defining thetas and everything, and you'll have to do a lot of geometric calculations. It is reduced somewhat using the DH parameter, and there is a formula which you have to go on using again and again. You need not calculate everything and go on solving the things again and again in different with respect to different axis of rotation, with respect to different translation. You don't need to do that. So it actually standardizes kinematic analysis. It also simplifies the forward and inverse kinematics. So forward and inverse kinematics is something that you'll be seeing in the next week. So you might be going through the lectures for them. So I hope you understand the difference between forward and inverse kinematics. If not, we'll have a problem for the same. It also reduces the number of transformation matrices needed. So you might require more number of transformation matrices for going from one frame to another. But yeah, in this case, it is reduced and it is very systematic way of doing things. So the advantage of this DH parameter, yeah, the advantage of this DH parameter is that it simplifies transformations, means you have less manual calculation to go from one coordinate frame to the other. It is a standardized approach. So it has consistent frame assignment. You might have seen that Z axis is always placed coming out of the plane and it is always kept parallel. So there is a rule that if you have a revolute joint, all the Z axis should be in the direction along the axis of the revolute joint. If it is prismatic joint, then you must have the Z axis in the axis of that prismatic joint movement. So this is standardized approach, whereas you won't have these if you are going to follow if you're not going to follow DH convention. Then it is a compact representation because for every link you just have 4 parameters and it makes the work easy for kinematic modeling. It has efficient calculations. It has software compatibility. So ROS and MATLAB do support them. Error reduction and scalable design, because if you have multiple number of links, you will have multiple degrees of freedom, and these DH parameters serves as a very systematic and consistent way of doing the calculation. So it is good. Just a just a brief recap from what you have learned already in your slide from DH parameter. That Z-axis is the axis of rotation or translation, right? And X-axis is the shortest shortest distance between the Z-axis. So I already told you how the Z-axis is placed, and X-axis is along the shortest distance from the in between the Z-axis. And if the Z-axis are intersecting, then X is perpendicular to the plane containing the Z-axis. If not, it is just the shortest distance between them. All right. Now, Let This was the example already taken, and just to visualize that how it was done. So you have already seen that this is a fixed joint, and then you have a revolute joint placed over here. Then this is the prismatic joint, and then you have again a revolute joint. So if it has three number of joints, three direction of movement, so it is definitely a RPR robot, has 3 degrees of freedom. So you might have learned that we are placing 0, 1 and 2 axis here only at the revolute joint. We could have kept this 0th frame at the base also, but that would just add to another link parameter. So we can shift it here also. So the global frame or the 0th frame, just a second, someone is here. Yeah, so the 0th frame can just be kept here, and then first frame is for the revolute joint, so it is here. The second frame is for the prismatic axis, so Z2 you might say it is along the axis of the prismatic joint. We can place it somewhere else also, but yeah, we'll like to coincide it for seeing if they are parallel or not, and the distance can definitely be taken into account. Then the third is a revolute joint, where also you can have Z and X axis. So this revolute joint movement is in this direction. I'm not able to use a pen, but you might understand it is going into the plane and out of the plane, that sort of movement it is. So Z is perpendicular to the axis as well. So Z1 and Z2 are intersecting. Hence, Z1 and Z2 are intersecting. Hence, we have X to be perpendicular to the plane of Z here. All right. So I think all of these things are clear. Now this was also, so you have learned the 4 parameters that are really essential, and all of them play an important role in shifting the origin from the base frame to the reference frame. So these are the 4 things: alpha, A, theta, D, where alpha is the link twist, A is the link length, theta is the link angle, and D is the link offset. All right. Now, uh, I think I can turn on my camera. I'll check. No, I cannot. Okay. Okay. So A is the distance between the Z axis. Alpha is the angle between two Z axis. D is the distance between the X axis, and theta is the angle between the X axis. That's all. So A is distance. A is distance between the Z axis. Alpha is the angle between two consecutive Z axes. D is the distance between X axis, and theta is the angle between X axis. All right. Now, this was a very simple problem that I had plans to take, but with the problem that I have of not writing, yeah, it is added. I think I'll be able to connect now. Just a second. Give me 2 minutes. I'm trying to connect. By that time, you can try to write the DH parameter for this 2R manipulator. Please start writing. I'm just trying to connect. Meeting. Just a second, I'll be back. presenting window. Okay, recording screen. Okay, I think now I'll be able to take this. Okay, so this is the problem that I was talking about. So it is basically a two-DOF planar manipulator. Why it is two-DOF? Does anyone have an answer to this question? I mean, you can answer in chat as well. It's not an issue, but why is it called two-DOF? Two-DOF is degrees of freedom. And why is it planar manipulator? Any idea? Okay, so yeah, you should know this. So two-DOF manipulator, because you are having 2 degrees of freedom here. How you are having 2 degrees of freedom here? This theta 1 and theta 2 basically govern how your end effector will be placed. Okay, so you have the motion in x and y direction, right? This, if this is y, this is y, this is x, all right? So you have the motion in both the directions and you have no motion in the z direction. Hence it is two-DOF, all right? And this is a planar manipulator because there is no motion in z. Make sense? Now, we are taking into account the forward kinematics. We are taking into account how DH parameter is being used for forward kinematics. So we'll see this. So the first thing is, let's say this 2R manipulator has L1 to be equal to 1 meter, L2 to be equal to 0.8 meters, theta 1 to be 45 degrees, theta 2 to be 30 degrees. Then I want to find what is the position and orientation of the end effector. So what is end effector? This thing. So we basically want to find what is this x, y and theta. Okay. So we are interested in finding this out. So we are having a two-DOF manipulator as an example to demonstrate how DH parameters help in forward kinematics. So before that, we would see that the robot has two joints and it has two links and everything that you are familiar. Now we need to determine what is the position and orientation using the DH parameter. So let's make the DH parameter table. So if I say I would define joints and then I would have A, alpha, D, theta. This is the, this is the distance along z axis. This is the angle between z axis. This is the distance between x axis and this is the angle between consecutive x axis. The joints that you have are 1 and 2. So this basically means 0 to 1 and this means 1 to 2. Okay. Now let's say we place our frame z axis to be coming out of the, change the color of my pen. Yeah. Z axis to be coming out of the plane. X axis, where would the x axis be placed? Let's say somewhere in the global frame. Okay. Let Z0 also be the same because it would be also in the same direction, right? So Z1 is here. X1 would be in this direction. So X1 is here. Then at this point, again, Z2 is parallel to Z0 and Z1. X2 is along this axis, right? Y is definitely a cross product of both of these. Now we want to fill in this table. So what is the distance between two consecutive uh, z, in between z0 and z1? It is 0, right? What is the angle between the z's, z0 and z1? It is also 0. What is the distance between x? So x0 and x1 both are intersecting, hence the distance is also 0. What is the angle between the x's? So x0 and x1 have an angle of theta 1 between them. So we'll write here theta 1. Alright. Now we'll take into account for 1 and 2. So this is 1 and this is 2. So we'll work for them. So distance between z's of distance between z of first link and second link is L1, right? Then the angle between the z of first and second link is 0 because they both are parallel. Okay. Then the distance between x of 1 and 2 is 0 because they are intersecting. And the angle between the x is theta 2. So this is your DH parameter for this 2-DOF manipulator. I hope this makes sense. Now, so what is forward kinematics? We want to find the end effector position. So why this is called forward kinematics? And what is inverse kinematics? Any idea?
In forward kinematics, we will find the position of the end effector by knowing the angle, everything of the links. Whereas in inverse kinematics, we will be knowing the manipulator position and we have to find out the link angle, everything.
Exactly. Very good. So when we are interested in the end effector positions and let's say we have these angles and everything given, so if we want to find out the end effector position, it is forward kinematics. Whereas if you are said that okay, you have to bring the end effector to this position at this orientation, and then you want to find out what are the joint variables, then that is the case of inverse kinematics. So I'm just demonstrating here how DH parameters can help us calculate what is the end effector position and how DH parameters simplify the process of calculation in calculating or in this process of calculation of forward kinematics. Okay. So now since we have we have the DH transformations already there. Now we'll write the homogeneous transformation matrix. Okay. I'll write it other way. Okay. So this would be, since everything is being done about z axis, we'll see how do we go from this zeroth uh, zeroth link to first link. No, zeroth joint to first joint essentially, 0 to 1. Okay. So it is about the z axis. So it is sine theta 1 and it is 0. It is 0, 0, 0, 1 here. You all know that. It is also 0, 0, 0. And here it would be sine theta 1, cos theta 1, and it would be 0, and this also would be 0. I think I have done, yeah. So this is the transformation matrix when you want to go from 0th frame to first frame. Okay. What is the angle? The angle is 45 degree. Put the angle to be 45 degree here. Because this is what you had, no? Yeah, it was only theta 1. When you substitute the angle theta 1 to be 45 degrees, you'll get the matrix where it would be 0.707 minus 0.707, 0, 0, 0.707, 0.707, 0, 0, and then it would be 0, 0, 1, 0, 0, 0, 0, 1, right? So this is the matrix that you will have. Okay. Now, after doing this, we'll do everything for, so this was for joint 1. We wanted to go from 0th frame to first frame. So this was everything for joint 1. Now, for joint 2. Okay, so it would be 1 to 2. Then you will again have these. So it is again the rotation about z axis. It would be cos theta 2 minus sin theta 2. Then this is 0. Then this is sin theta 2, cos theta 2, 0. And this is 0, 0, 1. This is 0, 0, 0, 1. What would be here? It would be L1, right? We have L1 coming up here. Here. So this L1 is basically the translation of, along the x-axis. That is why L1 comes here. And this is 0, 0. Substitute all the values here. You will get them to be equal to 0.866 minus 0.5 when you substitute the value of theta 2. Alright. So theta 2 is 30 degree. And here it would be 0. Then here it would be 0.5, 0.866, 0. And here it would be 0, 0, 1, 0, 0, 0, 1. And L1 is equal to 1. Right? So 1, 0, 0. So this is the value you will get. Now we want to find out how do we go from this 0 to 2. Then that would be 0 to 1 into transformation matrix from 1 to 2. Alright. When you multiply all of them, you'll get something. You should also keep calculating this, but yeah, it would be 0.2588 minus 0.9659 0.707. This is the calculation that you'll get. Please calculate it yourself also. This is the thing that you get after matrix multiplication. All right. Once you have all of these, if I ask you that what is the position of the end effector? I mean, we were interested in finding out x, y, and theta, right? We have the transformation matrix also here. Now, after this transformation, how would you be able to tell that what is the end effector position? There was an origin, you came from the origin to the end effector position using the DH convention. Now from this matrix, from the transformation matrix that takes you from 0th frame to the link 2 frame, how would you be able to know what is the position of the end effector? Can someone tell me? How would you interpret this matrix, 4 cross 4 matrix? It looks similar, like, right? There is a rotation, then there is a translation, then there is 0, 0, 0, 1. So can you make sense out of this? Is that possible? Okay, I'll tell you how to do. Your position x comma y will be 0.707 comma 0.707. How did I write this? Just these values, because these three are the translation values, na? So the x1 is 0.707, y is also 0.707, and z is 0. So it is a planar manipulator. Anyway, we had to get z is equal to 0, right? And we have got it. Okay. Now, after this, if I tell you how would you find the rotation? Then I showed you the translation one. How would you find the rotation? Does this appear to be some sort of rotation matrix? If it is a rotation matrix, can you find out theta from here? Very simple. Please try. Else, at least tell me how would you do this. It's very easy. Okay, I'll tell you. This is cos theta, right? This is minus sine theta, right? If I ask you what is tan theta, what it would be? 0.9659 upon 0.2588. From here you will be able to find theta, right? Tan inverse of this quantity. Tan inverse of 0.9659 upon 0.2588. Whatever is the angle that you are going to get would be your theta, right? So from here, using this DH parameter, you have been able to calculate what is the what is the end effector position. So this DH parameter really helped you in getting the transformation matrices and reaching the end effector position. All right. So that is why it reduces the calculation. This is also used to find out this inverse kinematics. But yeah, we'll have the question later. It was just to show you how this is beneficial for us. All right. Now, this was a question that was already covered in the class. So you basically have two revolute joints present over here. Oh, I think. Yeah. So you have three revolute joint presence over here, and we want to see the transition between 1, 2 and 3. Okay. So this is 3R. So here also you are calculating A, alpha, D and theta. So I think you might have understood, because what I showed you in 2R manipulator, it is just an extension of that. You just have one more link present over here, and then you are calculating the distance between z's, and it appears to be L2 along the x-axis, and the angle between the axes is theta 3, right? It is the same thing. And then you have all the matrices present over here. You take a multiplication of all of them and you get this, right? So this is the thing only. So the generalized form that was also taught in the lecture is of this kind, where uh, taking the transformation or shifting the origin, all of those calculations are present here in a very generalized way, that how do you reach from one frame to the other frame. Okay, so this is the calculation that is used, where you have the combination of everything. Find theta, find A, find D, find alpha. Place all of them here. You have the transformation matrix between two frames. All right, so we'll be using this in the MATLAB problem also. I just wanted to know how many of you are familiar with MATLAB. If not, we'll start from the very basics. Else, we will directly move to the problem. So we'll see that at the end of the lecture. So knowing MATLAB is really important, and every class will have some questions on the or the other being discussed in MATLAB. Okay. So this is some lecture question only. I mean DH parameter thing only. Before that, I'll tell you something. So when we did this, where is the question? When we did this, instead of manually calculating the geometric transformation for each part, DH parameter actually allowed us to do systematic calculations. Okay, and it was just a repetition. When you have multiple degrees of freedom, you saw that for 3R also this is a good approach, because it becomes easy. You have just repetitive thing to be done, and by simply substituting the joint variables and link dimensions, forward kinematics became really easy for us, right? Okay. So as per the DH notation, if the two z axes are intersecting, then the x axis is taken where? Can someone answer this question? Very simple question. You can write in chat as well. I don't have any problem, but please pay attention. Okay. You say orthogonal to the plane containing z axis, right? Very good. Yeah. Z axis is, sorry, x axis is taken in this way. The parameter that indicates the link length in DH table is what? Link length in DH table. So there are four parameters: A, alpha, D, theta. Link offset, and this is joint angle. All right. So our link length is given by A. Okay. This, yeah, right. Okay. So this is the similar kind of question. It is a 3R planar manipulator, and we want to find out what is the first row in the DH table. All right. So this is really simple, right? We saw this question already, but still I'll take you through it. Please understand this very well, because DH parameter really sets up the very base for your robotics. So you should know this. Okay. And this is my link 1, this is my link 2, and this is my link 3. Now, so it is basically 0 to 1, 1 to 2, 2 to 3. This is the distance along Z, angle Z. Sorry, distance along distance between the Z axis along Z, this one. This is the angle between two consecutive Z axis. Then this is distance between X, and this is angle of X axis. Now, if so, it is already given to you, but let's say my Z axis is in this direction, coming out of the plane. Okay, and my x0 is along this direction, x1 would definitely be along this direction, and z1 would also be coming out of the plane, right? It would be along z0 only. Ask me any question if you have any confusion in this. I mean, it is a very general way of defining the convention, since we are assuming it to be coming out of the plane. For the link 1 also, it would be coming out of the plane, because it will take the z axis to be in the same direction that is perpendicular to the link. Okay. Okay. So x1 is along the direction of the link. Then here you have z2 coming out, x2 here. Then here you have z3 coming out, and x3 here. All right. Now, what is the distance, or what is the link length? What is the distance between z0 and z1? It is 0, right? What is the angle between z0 and z1? 0. 0. Okay. And this is also 0, and this is theta 1. Very good. I'll write the complete DH table for the convenience, but yeah, this is the correct option directly. Okay. Between 1 and 2, it would be L1 is the distance between the two Z axis. The angle between the two Z's, Z1 and Z2, is 0, because both of them are parallel. The distance between the x's are 0 because they are intersecting. And then the angle between the two axes, two x-axis is theta 2. Similarly, here it is L2, 0, 0, theta 3. All right. So this is the way in which you write. So again, it is the question related to the same robot. The second row of DH table is what? It is L1, 0, 0, theta 2. This is your correct answer. Okay. Okay. Moving on to the next question. This is a 3-DOF RPR manipulator that is shown here. What is the second row of the DH table. We want to find an answer to this question. Okay, let's do it. So in this question, you can see x0, x1 and x2 both are, all of them are taken together. Why do you think we take this together? I mean, we could have z axis on the base, and then uh, x2 could be along the prismatic joint. Why do we have it all of them to, why do we have all of them together? Is there a reason for it? Are we doing something to simplify our calculation? Any idea why we are doing this? Okay. So this is being done just to simplify our calculation, because instead of x0 here, if we had, let's say x0 here and z defined in some direction, let's say z was defined here only, what would have, sorry, let's say I would have defined z0 to be like this, what would have happened? It would just have been matter of this link length and nothing else. Just one more thing would have come into picture. That's why instead of going through all of this, let's not do this. Place the zeroth frame here and then start the calculation. Whatever you are going to get for end effector, it would be with respect to this frame. Now this is just a link length, no? You can always add it in the in a particular axis. So it has nothing to do. Everything would be with respect to this origin. That's why. Okay. Now we want to write the DH parameter table for this. So it is A, alpha, D, theta. Here it is 1, 2, 3. It is again distance along the x-axis in between two z-axis. It is the angle between z. The distance between x, it is angle between two x-axis. Okay, this is 0 to 1, this is 1 to 2, and this is 2 to 3. Okay, can someone, before solving the question, I want to know the DH parameters from you for all the three rows. Please write and tell me, what do you think? I mean, I'll start going through it, but if you have the answers, please write them in the chat box. Okay. So what is the distance between two z's? You can see that z0 and z1, it is 0. What is the angle between z? It is also 0. What is the distance between x? x0, 1, all of them are together. Okay. Yeah. Complete row answer if you can give. That would be great. And what is the angle between 0 and 1? In between the x-axis, it is also, it is theta 1. Because this is a revolute joint, right? This is a revolute joint. It is able to move in this direction. Yeah, 0, 0, 0, theta 1. It is able to move in this direction. So theta 1 is the joint angle that you have here. All right. That is why we have the angle between x-axis to be theta 1. Now moving on to the second row. The distance between x, between the distance between z, z1 and z2, what it is? 0, right? Because both of them are intersecting. Yeah. And we have an angle between z. What is the angle between z 1 and Z2, it is definitely 90 degree because we are taking it in the clockwise direction from Z1 to 2. It is going to be minus 90 degree. Okay. Uh, yeah, this is the correct answer. So, what is the distance between x? It is d2, right? Because this second frame is fixed on the prismatic joint. So you will have a distance as soon as you move your x2 now, there will be a distance between. So if this point comes here, this x2 will be here, and hence you'll have a distance. This distance is given by d2. Okay, and the angle, there would be no angle because it is a prismatic joint, so you don't have any angle between x's. Both of them are parallel. Between 2 and 3, it is 0, right? Because the distance between z's are not there since they are intersecting. Then what do we have? Yeah, angle between z's. Angle between z is also 0. Both of them are parallel. And then L2. L2 is not mentioned here. Here this thing. This distance is L2. Okay. So the distance between the x-axis, both of the x-axis, x2 and x3 is L2. And then the angle is theta 3 because it is a revolute joint. Okay. So the question asked was for which row? Second row. So in second row you have 0, minus 90 degree, d2 and 0. This is the correct option. I hope it is clear. Okay. Moving on to the next question. For the manipulator shown in question 3, the coordinates of the origin of frame 3 is given by. Let me go to question 3. Yeah. Okay. So they are asking what is the coordinate of frame 3. Basically, here. What is the coordinate? What it would be? You can take the projections like this. I'll change the color of the pen now. Okay. I'll take the projection like this. And I'll also take the projection like this. Now, what is this in total and what is this in total? That is your only answer. So this is L1 cos theta 1 plus L2. So if this is already theta 1, so theta 1, L2 cos theta 1 plus theta 2 is your first coordinate. X coordinate basically. For y coordinate, it is L1 sine theta 1 plus L2 sine theta 1 plus theta 2. This is your y coordinate. All right. So what is the answer here? This is your answer. All right. I hope this makes sense. Okay. Moving on to the next question. Yeah.
Ma'am, can I ask you here? Ma'am, what will be the difference if frame 2 is to be considered? Coordinates of origin from frame 2.
If it is for frame 2, yeah. If it is for frame 2, no, then you'll have to take into account this only. So what is the coordinate with respect to the global frame or the ground frame that you have? So this is your ground frame. Your coordinate is 0, 0 here. And what is the coordinate over here? So your coordinate in this case, in your case which you're saying, would be L1 cos theta 1, comma L1 sine theta 1. Just this in frame 2. All right. Okay. In frame 3, it is because I want to find frame 3 means जो तीसरा लिंक है उसके बारे में बात हो रही है. In the frame, you're sitting on that frame. And if it is frame 2, it is for this frame. If it is frame 1, then it would be 0, 0 only. Because frames coincide there. Okay. Now, moving to question number 7. For the same manipulator that we saw now, the total angle that x3 makes with x0 axis. Okay, I'll go back. x3 makes with x0 axis. Your x3 is here, right? And 0 is here. So it is essentially a combination. I'll show you how. See, the first angle is along this line, right? How is this? And it is making some angle of theta 1. The second angle is actually somewhat is actually moves by this theta 2 angle. So it would go somewhat here. So this would be theta 2. So the frame 2 makes an angle of theta 1 plus theta 2. Now if we talk about theta 3, it is again rotated by this angle, theta 3. So this theta 3 frame, I had to make it parallel, it is not, yeah. The theta 3 frame is making an angle of, this is x0 now, and this is x3. So the angle between them is theta 1 plus theta 2 plus theta 3. Combination of all of these is the angle between the x's of both the frames, 0 and 3. Okay. So it is going to be theta 1 plus theta 2 plus theta 3. Okay. This is a SCARA robot. Okay, how many degrees of freedom does this SCARA robot have? How many degrees of freedom does this have? Yeah, it has 4 degrees of freedom, right? So why it has 4 degrees of freedom? Because the first joint that we have is a revolute joint. The second joint is also a revolute joint. This is a prismatic joint, and this is again a revolute joint. All right. So we want to write the DH parameter table for this robot. Okay. So I'll construct it in one go. So let's say this is A, alpha, D, theta. 1, 2, 3, 4. Always write this. This helps, really helps. Okay. In between 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Okay. Now, after this, the distance between the z-axis of 0 and 1 is 0. Angle is also 0. Distance between the x-axis of 0 and 1 is 0. And the angle is theta 1 because it is a revolute joint. So it is going to rotate and cause some difference in angle. Okay. If in between 1 and 2, what is the distance between z's of 1 and 2? It is L1, right? What is the angle? It is parallel and hence it is 0. What is the distance between x1 and x2? It won't move always, right? It is going to remain the same and it is 0. What is the angle? Just a second, I'll admit. Yeah. What is the angle between the x-axis, x1 and x2? So with respect to x1, x2 is about allowed to rotate. Yeah, theta 2, right, very good. Now we'll do for 2 and 3. So this 2, the distance between z2 and z3. So this is your z2, this is your z3. Now this z3 is fixed on the prismatic joint. So it is allowed to move in this direction. If it is allowed to move in this direction, the distance between the uh, z's, I think I'm going right. Yeah, z2 and z3 will remain fixed, right? So it will always be L2 only. We'll have the scenario different. The angle between z1 and z2 will be 0. And the distance between these x's would not be 0. Why? Because it is a prismatic joint and the origin will move with respect to the movement of this prismatic joint. So we'll always have some difference there, and it would be d3, and the angle between x is 0 because both of them are parallel. You can see that. When we consider 3 and 4, the distance what is the distance between z? It is 0. But you see there is an angle between z3 and z4. It is 180 degree, right? I hope this makes sense. What should it be? It should be 180 degrees or minus 180 degree. What do you think? 180. Why 180? I mean, if you're going from Z3 to Z4 in clockwise direction, then should it be 180 or minus 180? Yeah, that's true. So you can have both of them. But I generally prefer to have clockwise convention, and I put minus 180 degree there. It's going to give you the same answer because anyway you'll have sine to be cancelling out and cos theta is equal to cos minus theta. So the answer would remain same. I know that. But yeah, you can have some if you want for following the convention, if you consider clockwise to be negative, else you can have it to be positive. Okay, now this is the distance between both the x-axis and it is L4 only. Yeah, and this is theta 4. So your question was uh, the first row of the DH table. So it is 0, 0, 0, theta 1. This is your answer. Okay. The next question is, for the SCARA robot, the third row is given by what? It is given by L2 0, D3 0. So this is your correct option. And then for the SCARA robot shown in question 8, the fourth row is given by what? So your fourth row is given by 0, 180, L4, theta 2, theta 4. Right? So this was the way. Okay. Now, this is the same SCARA robot. We want to find what is the homogeneous transformation matrix for this SCARA robot with the 4 joints. Given the DH parameter. So this is the DH parameter that is already given to you. Alright. And then you just have to calculate the complete homogeneous transformation. So there are 4 links, right? So we want to find how to go from 0 to 4. So it would definitely be a combination of 0 to 1 into 1 to 2 into 2 to 3 into 3 to 4, right? So we basically want to find out, okay, what are these transformation matrices? If we have these transformation matrices, multiplying them will give us the result. Now, what are these transformation matrices? They can be found out from DH parameter. Now, how DH parameter will help us find these transformation matrices? So we already saw that this is a very general version. So if you substitute the value of theta here, if you substitute the value of alpha here, because this is a general way, it is not problem specific. Any theta you have, any alpha you have, if you have the DH parameter with you, you just plug in the values here and you get the transformation matrix between two consecutive frames. All right. So just plugging in the values here would help us get. But the thing is, this transformation matrix would, let's say this is 0, I minus 1 and I is 1. It would take you from 0 frame to 1 frame. So that time theta, alpha, everything is different. Now, I want to, let's say, go from first frame to second frame. So theta, alpha, everything will be different again. So what we want is every row of the DH parameter table should be passed one by one through this matrix to get the transformation matrix, and then multiplying all of them would help us get the result. So I want you to write a MATLAB script. I'm sorry. that that calculates a complete transformation matrix from the base frame to the end effector frame. Okay, using these parameters, and it should include a function to generate a general transformation matrix for any given DH parameter. Okay, before that, I just want to know how many of you are already familiar with MATLAB? Any experience in MATLAB? I just want yes or no answer so that I can decide that from where I have to start. And you'll get the codes. I'll be giving you the code in the slides as well. So you have a spreadsheet, right, where you have the presentation and the PPT share. So the code will be present over there as well. But just tell me if you are familiar. No simple MATLAB programming and Simulink. Okay. Okay, okay. I'll change the recording screen. Just a second. Okay. I hope the MATLAB window is visible. So what I'll do is, yeah, I'll show you. Okay, before that. So let me take it to full screen. Yeah. This is basically the editor part where you generally write your scripts in any form and then you want to compile them and execute them. So the complete script writing can be done here. Okay. This is a command window where you can see the value of intermediate variables. For example, there is a long program and you are doing so much calculation, but for debugging, you need to see, okay, what are the variables in between that are changing. So you can use this command window to directly say that, okay, if a was my variable here, kindly print that. What was the value stored in it? Here is the workspace where you can generally save all your where you can have the format type of all the values and you can have them written in structure form or some time series format and you'll be able to access them. And this is the part where you have the folder just being opened. So just now, I already showed you this thing, that you have a SCARA manipulator. You already know what is a DH parameter table. Let's say you are given some values. Are you able to find out the complete transformation matrix? So that is the code we'll be using. If you have MATLAB already installed in your system, please open it and start coding with me. It will help you a lot. And yeah, so let's start. So the first thing we do usually is we write CLC, because we want to clear the screen and clear anything that is in command window. We also write clear all, because we don't want to have anything in our command window or stored. Then we want to write close all. If any graphs are opened or any other thing is opened, I want to remove them. All right. Now after this, I would be defining the link constants. All right. So in our case, okay, in our case, we just had L1, L2 and L4, right? Uh, I would suggest you a thing. Uh, just a second. Uh, please take a photo of the screen that you have, so that we can begin with the MATLAB programming. I hope it is taken. Okay. Now, I'll move to MATLAB again. Okay. I'll be assuming some values. You might have seen that we just need L1, L2 and L4. Okay. Uh, okay. So now we'll start. Let's define all the link parameters. And joint variables. Okay. So I'll have L1 to be equal to 1. All right. Put a semicolon always if you don't want it to get printed. If you don't put a semicolon, after execution, you will have it being printed again and again. So execute those, leave semicolon there only where you want the prints. Else you terminate that. Okay. Okay. L2, let's say I'll take it to be 1 again. Okay. L4, I'll take it to be 0.5. All right. We also have theta 1, theta 2, D3 and theta 4. So theta 1 is equal to, let's say I take it to be pi by 4. So pi is written in this form. Don't write the value of pi 3.14 and all. You can directly use this. Okay. Theta 2 is equal to, let's say, pi by 6. Okay. Then we had D3. Yeah. D3 and D3 to be, let's say, we say that it is 0.2. The prismatic joint is able to move forward and backward only by a distance of 0.2. And then theta 4 is pi by 3. Okay. If you have any problem, please stop me. I'm right now not even on the Meet screen, so I won't be able to see your chats. So do speak when you want to ask anything or convey anything. Okay. Okay, so this is done. Now it is just that I have to substitute this value somewhere. Okay, in some I really want to use these values to calculate the transformation matrix. So for calculating the transformation matrix, I'll be making a DH parameter function. Okay. So, and for MATLAB, the rule is that function always has to come at last. No matter wherever the function is being called, it has to be placed at the end. So we'll first write what is the function. Okay. So this is the function, sorry, function to calculate the transformation matrix. All right. So let's say I define some function t which is equal to dh transform. Okay, this is my function, and what it would take, it would take a alpha. What would be the arguments? A alpha okay, I'll write d and then theta. Okay, this is all it is going to take. Now inside the function, what I'll write, let's say I define cos theta. What is cos theta and what is sin theta? Because I'll be using it again and again, right? So I'll be defining it in some simple way. So it would be cos of the argument passed, and argument is theta. Okay, then I'll have okay, then I'll have cos alpha so my theta is in radian, right? I also have to pass alpha through it. So what should be our alpha? So you can remember from the DH table that we have written alpha to be equal to 180 degree in one place, right? If it is in degrees, then we need to make the calculation also in degree, because we didn't write it as radian, right? If you write it as radian, no, you'll be able to pass pi directly. For example, I'll just for clarity, I'll be passing here 180 degree and not pi. So I'll show you how that is also done. So for that we use cos d. So it is used for taking alpha in degrees. Okay. So you can see the difference. Both of these actually take theta in radians. Okay. But if I have used cos d instead of cos, so it takes it in the form of it takes it in the form of degrees. So here again I'll write for alpha, I'll write degrees only. It will introduce you. Then it will be sine d. You can definitely not have d here and directly use pi, pi and not 180. Okay. Now after defining all of this, what we really want to do is we want to write the transformation matrix. What is a transformation matrix? So the generalized form is written by cos c theta minus s theta comma 0 comma a, right? This is what you all also know. Okay, in the second row it is going to be sine theta into cos alpha, right? Comma cos theta into cos alpha, right? And then it is going to be, correct me if I am wrong somewhere, okay? You already have those matrices with you. Minus sine alpha minus sine alpha into d. All right, this is the second row of the generalized format. The third row is sine theta into sine alpha comma cos theta into sine alpha comma cos alpha comma cos alpha into d. Okay, the fourth row is, it's very easy, 0 0 0 1. All right, so this is your complete transformation matrix. Once you are done with the function, just write end here. Now what we'll do, we'll call this function in our main program. Okay, and how we'll do, we already have this written. Now what we'll write for the first one, t1. Okay, so t1 is equal to our function is dh transform. Dh transform, what are the arguments? 0 comma 0 comma 0, sorry, 0 comma theta 1, sorry, right? What is our t2? I'll just copy this. Dh transform of L1 0 0 theta 2. T3 is equal to L2, then 0, then it is D3, and here it is 0. All right, T4 is equal to 0 180 0, sorry, L4, this was right, and this is theta 4. Okay, now after doing this, what we'll do, we will calculate the complete transformation matrix. Okay, so T let's say is my transformation matrix. It would be T1 into T sorry T2 into T3 into T4. Okay, this is my transformation matrix. Now I want to display the result. I can directly display this from here itself by not putting a semicolon, but I'll write a line and display. So okay, and I'll write a display display, and what I want to display, it is T na. T was the thing I gave, yeah. Display T. Okay, our program is done. Let's run this. Okay, so this is the complete transformation matrix. Okay, after the multiplication of T1, T2, T3, T4. So this is the way in which you can define a function, and after defining the function you can just call that function and over again. And what do? We try to find out T1, T2, T3, T4. All of them are going to be uh, the transformation matrices from one frame to the other frame. And from one frame to the other frame, you already have A, alpha, D, and theta. Just plug them in. You get the transformation matrix, multiply of all of the transformation matrix. You get the final transformation matrices. Whatever is the final transformation matrix, that will give you the end effector position and orientation. The way we saw for 2R manipulator, same goes for 3R manipulator as well. We'll be able to find all of them. All right. I hope it is clear. So just a second. Uh, where is my wireless display? Okay. So here you can see that we use this general matrix. You have the code as well already written in the PPT, so you'll be able to use it directly if you need. And thank you for the today's lecture. I hope you are clear with the DH parameters now. And if you have any questions, you can ask me right now. And we'll have forward kinematics and reverse kinematics questions being taken up in the next class, because that is all you have for uh, the next week lectures. I hope you are able to do the assignment properly with these DH parameters. If you have any questions, please feel free to ask. Um, yeah, the exam is in English, so you can always take the exam, and I guess it is allowed. I mean, you can register and take the exam, but the problem is that probably you'll have to be present here, because it is a computer based test, and that would be taken at the centers in India only. So I think you'll be able to register even as a foreigner, but you'll have to take the exam here. So that could be the thing. One more thing you can do is you can write a mail to NPTEL asking all your queries. All right. Please ask them, please work. Yeah, you can come to India and take the exam. But still, I would like that you should clarify this. So you see on the course website, I mean on the link that you have been shared from NPTEL, you have discussion forum over there. Please raise the question there. I guess the correct people will answer, and I don't think it would be a problem to uh, if you are ready to take the exam after coming to India. Okay, any more questions? DH parameter is all clear?
Yes, ma'am.
Okay. Okay, then we'll meet next Monday. See you. Please get hands-on MATLAB. It is really important. In the next class, we'll have probably questions on forward and inverse kinematics with some simulations in MATLAB as well. So I request you to go through the lectures, get some experience with MATLAB, and try to get MATLAB installed in your system so that we can parallelly code. So as I am writing the code here, you should also be doing the same thing. It would be fun and you'll be able to make many interesting simulations in the future if you are well versed with the basic capabilities. So please do it. Okay, thank you. See you next Monday. Yeah.